In this video, we will see why the data from Fill It Up Inc. on the left is proportional and why the data from Bottles by Bob on the right is not. First, let's look at the similarities. The cost of the water bottles increased by a constant amount for both companies. If we look at the table in Fill It Up Inc., you will notice that one bottle costs $4 and that 5 bottles cost 5 times 4 or $20. The cost per water bottle does not change. You will see that in the graph, when we graph these points from the table, that it shows up as a straight line. If we look at the table for Bottles by Bob on the right, the cost for one water bottle is $3. So the cost for 5 water bottles is 5 times 3 or $15. Again, the cost per water bottle does not change, and when graphed, it makes a straight line. And because of the constant increase, both equations have a calculation in which the cost per water bottle is multiplied by the number of water bottles. So for Fill It Up Inc., we see the 4 being multiplied by n, the number of water bottles, to determine the cost. And in Bottles by Bob, we see the cost per water bottle of $3 being multiplied by n as well, the number of water bottles. Now let's look at what are the differences. The table on the right here, the data Bottles by Bob, starts with $25. That causes the graph to start at $25 on the y-axis. Therefore, the equation needs a second number in order to calculate the total cost. We must show the starting amount here as plus 25. So where's the proportionality? Let's find it in multiple ways. First, let's set up a proportion from the data in the table. Remember, a proportion is a set of equal ratios. We are going to compare the number of bottles to the cost using the data from the table for Fill It Up Inc. We can see in the table that one water bottle costs $4 and 5 water bottles cost $20. The data is proportional as the number of water bottles and costs are both scaled up by a factor of 5. And another example, if we take one water bottle costs $4 and 20 water bottles cost $80 as seen in the table, again, this data is proportional as both the number of water bottles and the cost are scaled up in this case now by a factor of 20. In fact, any pair of numbers from the table on the left would form a proportion. We would say that this data is proportional. But no proportions can be set up from the data in the table on the right. If we try to compare the number of bottles to the cost, and we use the data from the table, we have one water bottle cost $28, 5 water bottles cost $40. This is not a proportion due to the different scale factors on the top and the bottom of the ratio. In fact, no proportions will be found in this data. And we would say that this data is non-proportional. Next, let's identify the constant of proportionality. On the left for Fill It Up Inc., we have a constant of proportionality of $4 because every number of water bottles can be multiplied by 4 to calculate the cost. On the right at Bottles by Bob, this data is not proportional. Though it goes up by $3 per bottle, there is no constant of proportionality. You can see this because there is a different factor that's being multiplied with the number of bottles to calculate the cost. Next, let's look at the graphs. A proportional graph is a line starting at the origin or the point 0, The graph was made from the data in the table, therefore it's proportional because the data in the table was proportional. The constant rate of change also known in this case as the constant of proportionality, shows up in the y-coordinate when the corresponding x-coordinate is 1. The graph on the right is a line, so it does have a linear relationship, but it does not start at the origin. It was made from the data in the table that did not have proportionality, so the graph is not proportional. Lastly, let's look at the equation. A proportional equation will have the constant of proportionality as the multiplier, and that is it. In this case, the 4. The equation on the right is not proportional because it also has a starting number of 25. As we can see in the equation as a plus 25, we can also see this in the table.